Hello, this is Ireza Ghaffarian with the UTC ID RVW611. This is my homework 2 from parallel course, and I'm going to present my homework 2 PThread assignment. The idea is uh, I start a bunch of threads. Each thread keeps picking a random unsigned line below a maximum value and checks if it's prime using a simple trial division test. If the thread finds a prime, it returns that number. If it uses it, if it uses up its allowed attempts, it returns zero. At the end, the main thread joins all the workers and prints one line per thread saying either no prime or that X is prime. I compiled with the with this line GCC dash cd C11 dash wall dash O3 dash O P thread. This is my file's name. And at the end, dash L P thread. And I run it with this dot dash P thread. This is my file name. And this 100 is number of threads, and this number and max try is 10, and max value is this number. If I don't pass anything, it uses those defaults. Um, and here you can see the results that I got. These are the prime numbers, and we can go to code implementation. And at the top, I define three defaults, number of thread defaults, max tries default, max default value. I also include a note about the randomness. And my function is prime ul unsigned line is deliberately simple and slow, which is the point of the assignment. If n is less than 2, it's not prime. If n is even, it's prime only if it's 2. Then I check odd divisors 3, 5, 7 up to uh, to avoid overflow. I use the condition d is less or equal to n over d instead of d dot d less or equal n. If any divisor divides evenly, it's not prime. Otherwise, it is. Random number generation per thread. Each thread needs independent randomness. I wrote uniform random UL max to state if arc for random buff is available, I use it directly. Otherwise, I can call my XOR shift 64 fallback using a per thread 64-bit state. I set that state by mixing time null, the thread ID, pthread self, and the threads index. That way, thread don't share RNG state, and I don't need any mutexes. The random number is reduced modulo max value, so it always lies in between 0 to max value. What each thread does is my worker function is thread main. It initializes the per thread RNG seed. It loops up to max tries, generate a candidate X in between 0 to max value. If it's less than 2, I bump it up. Call call is prime ULX. If it's prime, I keep it and break early. The thread then allocates a tiny unsigned line, writes either the found prime or the zero and returns that pointer. Returning via a pointer lets the main thread receive a value directly from pthread join without shared data structure. And main parse optional arguments for number of threads, tries, and max value. Allocate arrays for thread handlers, per thread arguments, and results. Start each thread with pthread create, passing index, max tries, max value. Join every thread with pthread join. I read the return unsigned line, save the value, free that pointer, and move on. Finally, I print the required line for each thread. Thread I reports no prime or thread I reports that number is prime. The output format matches the assignment sample exactly. When I run with 100 threads and 10 tries each, I usually see many no primes lines and several, let's see that. And I was saying, I usually see many no primes lines, and as you can see, and several prime founds that expected around 10 power 17. A random number is prime with probability about 1 over ln 10 power 17, roughly 1 in 39, approximately 2.6%. With 10 attempts in a single thread, has only about a 23% chance to find one. Across 100 threads, some succeed and many don't. So the mixed output is normal. Uh, why this meets the rubric? It complies cleanly with dash wall and dash big O3. It launches a configurable number of threads and collects their results. The primality test is correct, even though it's a naive by design. Style-wise, it's cleanly structured with clear names and minimal focused comments. Thank you so much for your time.